All right. I think we're all in. Hello and welcome to this webinar together with Basemark and Imagination Technologies. My name is Sofia Olsson and I'm from Basemark. In this 45-minute webinar, it's going to be packed with very interesting talks about mobile ray tracing and GPU benchmarking. Here with me today, we have Christoph Beetz, Vice President of Technology Insights at Imagination Technologies, as well as Tim Mamtora, Chief of Innovation at Imagination Technologies. Hey guys. And from Basemark, we have our CEO and founder, Tero Sarkinen, as well as Patrick Oyala, Head of Product Management at Basemark, and Mitra Kristea, GPU Score Product Owner at Basemark. Great. Welcome, everybody. We're so happy to have you here today. Just before we start, if you have any questions during the webinar, feel free to share them in the chat here on the right-hand side. And we will get back to them later in the end of the session where we have the Q&A. Good. I think we're ready to start. Tero, I think the floor is yours, or screen is yours.
All right. Thank you. So it's great to be here, and I'm really happy for our colleagues from Imagination being able to join us as well. So this is really great, and we aim to give you a very informative session, and we do hope that this is very useful and interesting also to all of you around the world. So my starting speech was going to be 20 years of benchmarking, but when I started to think about it, it should be 25 years of benchmarking. So although I personally only have done 23 years of those, but anyway, so basically benchmarking, like the modern GPU benchmarking, started about 25 years ago when Finnish game developer company called Remedy, which was working on Max Payne, wanted to know what kind of PC performances are going to be in 2 or 3 years from the present time, because that's when they were about to launch their game, Max Payne. So in order to do this, they spun off, they created a own company to create benchmarking software. This was FutureMark, and it was established in 1997. And we all may remember that like the first GPUs were launched around that time, like, for instance, Riva TNT in March 1998, so a long time ago. Well, I joined FutureMark back in 1999, and the first product I got to work with, mainly for sales and marketing, so launching, was 3D Mark 99 Max. It was utilizing the fabulous DirectX 6 API at the time with the fixed pipeline. So, and that's when I got my feet wet in the area of GPU benchmarking. Around that time, there were other benchmark companies around as well. One was called ZD-BOP, so Ziff Davis Benchmark Operations. And we had a really tight competition with them, who makes the coolest looking benchmark then. Also, there was Babco with their Sysmark product. So those were the days, certainly. And then time went on. FutureMark started really working on and getting the 3D Mark quite popular. FutureMark also started to do another product called Video 2000. Good colleague Ilkka Koho was the head of that, now working for NVIDIA. And then came PC Mark and so on. Personally, in year 2000, I moved to Silicon Valley to start getting business out of benchmark development. So this was the early days of PC GPUs, and there was a lot of companies. NVIDIA was one of my first customers, was a small company at that time, and also with Imagination already back then, we had the initial business dealings going on with many. So we can really say that we've come a long way, and it's been very nice always to work in this industry and with great companies like Imagination. So then we started to get towards the mobile benchmarking in year 2004. And you may remember that that's when Nokia launched 3650 phone, the phone with a funny round kind of a dial. Okay, it was nice looking phone, but most importantly, it was the first phone with OpenGL ES1 rasterizer, and it was a software rasterizer. So not not a very powerful one, but anyways, it enabled us to do a product called SP Mark, smartphone mark. So that's basically when this GPU benchmarking in mobile started to get hold, and that's when we started also having more and more dealings with Imaginations, since their GPUs are quite widely adopted in the mobile and embedded. So in year 2007, actually, personally, I got the first foray into automotive. So into later on, we will, as you can see, do also automotive GPU benchmarking. But this started back in 2007 when Audi had one nice meeting with me, and we started working with some graphic stuff on them. So in 2009, I founded Rightware, and I acquired these FutureMark benchmarks into Rightware. So all these OpenGL ES benchmarks came along. We branded those as Basemark ES1 and Basemark ES2 and ES3 for OpenGL ES different versions. But that was or when there was a very rapid development on the software rasterizer based OpenGL ES graphics APIs and GPUs, and the industry, some leading companies like Imagination, really turned out generation after generation better and more faster chips, but with very low power consumption. So this certainly has been the key thing in the mobile. Then basically in 2015, I founded another new company called Basemark. That's where we are today, and I acquired all of these Rightware benchmarking business into it. So now we can see that we've come a long way from Max Payne back in '97 onto this present time. And within Basemark, we then, Vulkan 1.0 got ratified, and we were like the first benchmarking company to put out a benchmark that stressed the Vulkan API. And in 2020, we began development of automotive SoC GPU benchmark called BATS, so Basemark Automotive Testing Suite. And again, happy to work also with Imagination on that. And that is now we can see sort of PCs, smartphones, cars. So I don't know what next, but certainly there will be. And then in this year, in beginning of the year, we launched the world's first cross-platform ray tracing benchmark called Relic of Life. And there's this ray tracing is now finally really possible to do with a meaningful performance and especially power consumption on mobile devices. And we've got a lot more stuff in the pipeline coming that deals with ray tracing, and in today's webinar we'll hear some very nice insights into that, and also hear the GPU IP or technology companies' visions and points of view into this. So with this, I really would like to again welcome our excellent speakers today. So Tim, Christoph, Mircha, and Patrick. And now, with these words, the stage is then yours. So thank you.
Thanks, Taro. And I think next up, let's see, I have some weird noises. Next up, we have Christoph Beats, who's going to open up a little bit more about mobile ray tracing and share us his thoughts on where it's going into the future. Okay.
Thank you. So indeed, a kind of brief introduction to ray tracing for mobile phones. Um, the first question we kind of always get is why would you consider ray tracing in a mobile phone product? And it's a very good question because obviously, as already mentioned, ray tracing is very computationally complex. But the real counter to that is the potential visual quality. Ray tracing really gives you the opportunity to significantly boost the visuals of your game, your application, because it's funded on how reality works, how light interacts with the scenes around you, and how everything works. And that actually means that the ray tracing mechanism, so following a ray and bouncing it around the scene and capturing all that interaction, makes a lot of effects quite simple because you're casting a ray and getting intersection information back, which is much simpler than a lot of the very complex approximations that we see in games and applications today, where you have hundreds, if not thousands, of lines of shader code that you need to implement shadow effects or reflections. So with ray tracing, we can really move away from those very complicated approximations and use the core building block behind reality, which is the tracing of rays. The good thing is ray tracing has also kind of been in use from the very beginning in 3D graphics, right? Even if you go all the way back to Quake, it had pre-baked light maps. And those light maps were generated using ray tracing. It was done offline, it was slow, but it was effectively using that same fundamental technology. The great thing is now, all these years later, we can move this from a pre-baking offline process to make it real time. And that really has quite a few benefits, right? Today, a lot of games with pre-baked textures, light maps, ambient occlusion, you may need gigabytes of texture data if you want all those rich environments. But now we can shift that and make it all real time and fully dynamically calculated. And that really translates into a lot more artistic freedom and a lot of more speed in terms of how you develop, because a lot of those algorithms are approximations. They have risks for artifacts and bottlenecks that as a developer you need to avoid. So really the reason for considering ray tracing, even on mobile phones, is all those benefits. The fact that the tracing of rays becomes a very efficient, fixed function, dedicated hardware processing step, which is a lot more power processing and bandwidth efficient operation than doing a lot of these very complicated approximations. The other key thing, of course, for adopting new technology like the ray tracing is the essential of ecosystem support. You know, it needs to be standardized. We don't want to go back to the very early days of 3D graphics where the market was fragmented and everybody had custom APIs. So the fact that we have got Chronos, the fact that we have got the DirectX standardization, and even in the Apple ecosystem, we've got the Metal API, and all of them today expose some level of ray tracing functionality. Of course, the next thing that we need is a kind of starting point in the market, so an amount of hardware that is out there. And the great thing is ray tracing is already everywhere in the console market. So both Sony, Microsoft, and today all the PC market vendors are supporting hardware-based ray tracing. So just a good, very good foundation for developers to invest in this. And a lot of that content transitions from there into the mobile market. And the great thing is we're seeing a lot of the mobile phone OEMs very excited about ray tracing in mobile. So a lot of them pushing already software solutions, which are of course not very performant and not very efficient, but it really shows that all those companies are very eager to adopt the ray tracing capabilities. And of course, we've been investing into ray tracing for quite a few years now with early development hardware, and there's a lot of interaction with a great set of companies worldwide, as you can see on this slide. Now, as always, hardware is a complexity, and it's very important for developers to understand some of the differences. And we've got quite a bit of experience with that. We were always different as Imagination with PowerVR GPUs. We were a tile-based deferred rendering architecture. And a lot of our competition at the time was immediate mode rendering. And we had to spend a lot of time explaining to the market why that was more efficient and how tile-based rendering really made mobile graphics possible, where with traditional immediate mode, that just wasn't efficient enough. And we really see the equivalent now with ray tracing as well. That is, hardware ray tracing is not equal across all the different vendors out there. Of course, you can go all the way from a level 1 solution, which is purely software based, so not very interesting, very power hungry, very low performance. But you can incrementally add more hardware and more intelligence into the hardware design to deliver you a more power efficient and more performance solution. Level 2 is kind of the most basic capabilities of ray tracing, that is adding dedicated hardware for ray box and ray triangle intersections. This is the most common in the market today, even in the PC space. You can go a step further by enabling full BVH, so the bounding volume hierarchy, the acceleration structure, so the full processing in hardware. So you give the hardware array and it will come back with the hit information. So you're offloading more because with the level 2, there's still a lot of things being done in compute kernels and software. And of course, you can then go further because one of the problems with ray tracing is coherency. Rays have a tendency, because of how reality works, to bounce in lots of different directions and go in lots of different uh, directions. And that means you hit different parts of the acceleration structure, you execute different shader programs. And that is really where different levels of coherency sorting come in. And the latest desktop hardware is adding backend sorting. So as you have your hits, you resort for coherency for the shader execution. We actually go a step further and we do full coherency sorting even on the rays. And the benefit of sorting the rays is that you bundle rays going in the same direction. And that means you get very high cache hits. And it's kind of the equivalent of tile sorting, right? So it's very similar to our tile-based rendering. We are sorting the rays so that we get very high cache reuse and very high efficiency. And that power benefit, that bandwidth efficiency benefit, is really what you need to enable ray tracing in mobile. So the visuals behind it, we have been creating quite a lot of demonstrations in-house to show how a lot of very complex effects can be achieved. So anything from soft shadows to different levels of reflections, to denoising solutions, but equally very important in our eyes is global illumination, because it makes a massive difference to the visual quality of it. And there's a couple of YouTube links here if you want to see all of this moving in real time. But really to show the differences, this is a scene which has ray tracing disabled, so it's doing cascaded shadow maps, it's using cube maps for reflections, but you see you're very limited in what you can do, and it's very easy to get artifacts with a lot of these approximations. So you can kind of see the banding effects here, which are very complex tuning issues to do with your shadow maps. The great thing is once you enable ray tracing, all of those things become much easier and the artifacts disappear. So you can see the very nice diffuse reflection. You can even see the character reflecting in all of the shapes in the environment. You can see as well that a lot of the shadows and their fuzziness all just works automatically. But like I said, we can go a step further by enabling global illumination. And you can immediately see that the whole look and feel of the scene changes, because all the dynamics between the light and the fact that it's darker over here because less light can reach it immediately is reflected in the scene. And that's really the great value that ray tracing offers you. All that realism, that correct interaction is much more straightforward to achieve. We did another demo together with O3DE, which is an open source game engine. And again, you can see the real benefits of global illumination here. So you can see where the sun is blocked, the scene is much darker. You can see that a lot of the scene is very dark and all the interactions of the light are working. Whereas if you look over here, the sun is not hidden by the clouds. You can see there's a lot more light, and immediately you can see all of the objects get a lot more light, but equally you can see the bounce effects. You can see the fact that the sun is bouncing from the building and illuminating the building across the road. You can do very simple things. Just change the color of the room, of the wall here, and you can immediately see how it impacts the whole scene. So with ray tracing, all those things, all that spatial and interaction becomes very, very straightforward and easy to achieve. And that really helps with the visual look and feel. And a lot of that is done with very small ray budgets, because you can do a lot of that approximation by using probes that capture the light information. So you don't need giga rays to do this. You can work with very modest ray budgets as you kind of spread out the update of those probes over time. So really the key summary for me is, ray tracing, the adoption is growing very rapidly, PC, console market, and we're even seeing that emergence in the mobile space as well now. And there's growing opportunities as well in the data center with cloud gaming for ray tracing as well. And ray tracing offers great value, right? A better visual quality, a lot of ease for the distribution of the content and the dynamics and the interactions. And it's a lot more power efficient as well. When you have the right hardware, it is much more power effective than those complex approximations. And that's really where it's very good to be aware that not all those hardware solutions are equal, and that especially in the mobile market, you're going to have to meet that investment in smart hardware that handles this processing in the most efficient way. But for the developers out there, controlling your array budget is very critical in the mobile space. And we've got a lot of guidelines and great examples out there for you. Thank you.
All right. Thank you, Christoph. Let's see. I guess we can move on to next topic on the agenda. And next up, we have Mircha from Basemark, who's going to talk a bit more about GPU benchmarking.
All right, so let me share document. All right, I guess it's visible for everybody. All right, so let's go through a bit over the general features and have an overview on GPU score. First of all, let's take a look at the general context of the benchmarks. So as Christoph already said, the real-time ray tracing is out there in the market for quite a while now, we can say. And so on the discrete high-end GPU market, we got real-time ray tracing for quite some time. But still the benchmarks are still quite few at this moment. And also at this very moment, there are efforts and there's pushing towards path tracing even on the discrete GPU market. So where is the whole mobile in this whole context? Well, throughout the years, the mobile market has been a bit behind the high-end discrete GPU market, but it has constantly following it up. And we could say that at this very moment, the gap between the mobile market, the mobile development, and the high-end discrete GPU market is getting narrower. So we could say that the mobile market is right now catching up and is like one step behind the desktop and the discrete GPU high-end market. But since the mobile is following up, of course, we as benchmarks, we are trying to get updated and to stay up to date with what's happening. So obviously the next step for mobile development is it would be ray tracing. And we can see that already in the market, because since 2022, we got already on the market mobile devices which feature ray tracing. And it has been observed in the recent years that the demand for hyperrealism and for high-end graphics on the mobile market, it has been increasing. And we can see that in many of the applications which have been released recently, and also especially in games, we can see that. But for everybody who has worked in games or has developed games for mobile, everybody knows that you cannot really get exactly what you want, and you have to cut off. And that is because of the hardware limitations. But of course, the mobile market now tries to reduce those limitations, and we are pushing forward to get more content, because the demand is there for more content and more realistic content in the games and in the applications. I gave here just a few examples of games coming quickly to my mind on the mobile market, which are employing quite high level of 3D graphics. So yeah, the demand is really high at the moment on the mobile market, and we are pretty sure, and we envision that the next step into the development will be in the demands of the gaming on the mobile market will be ray tracing, the employment of employing ray tracing. Now, in this whole general context, still the benchmarks for mobile are quite a niche, we could say, because there are few benchmarks out there which are targeting the mobile environment, and most of them, they are also a bit old at this moment. So this is where GPU score comes into place. But first, let's have a quick overview on the general features of GPU score. We have already a benchmark released at the beginning of 2022, as Tero said earlier, Relic of Life, which targets real-time ray tracing devices, capable devices. One very important feature of GPU score is that it relies on our in-house developed engine, which is rock solid. Well, that is the name of the engine, and this is a quite important thing, because all the features that we need to have in our benchmark application, they have to be implemented first in our engine. And also, one very important thing related to that is that Rock Solid is quite a proven engine, because we are now targeting products. We are looking into developing products based on Rock Solid for the automotive market, as Tero said earlier. So this gives like a solid proof for this engine, for Rock Solid. And a couple of features which we have in our ray tracing implementation, which we have in the engine implemented, are the global illumination, the reflections using multiple bounces, and denoising as well. And of course, there will be some more features which we are looking to implement into our engine, Rock Solid. Now, related to ray tracing and the way it was implemented in Rock Solid, initially we went for ray tracing pipelines, but having discussed and talking with our partners, Imagination is one of them, we concluded that the optimal way to go is using ray queries. So right now, the ray tracing implementation which we have in Rock Solid is a hybrid ray tracing using rasterization combined with ray queries. And related to the approach which we have on our tests, we prefer frame-based tests over the time-based tests. Of course, in our engine, we have optimized render passes for mobile, because what happens on the mobile is a bit different from what happens on the discrete high-end GPUs. And also because our engine has native support for multiple platforms, from Ubuntu to Android. Of course, in our benchmarks, we also have this multiple platform support. And we also have multiple API support, Metal, Vulkan, DirectX. We also have OpenGL, GLES, but that was used in Basemark GPU, and in the current benchmarks, in the GPU score benchmarks, we only have DirectX, Vulkan, and Metal. Now, the benchmarks which we are developing, they combine several tests altogether. So one application has both official native VRS, variable rate shading supporting test, custom test, and an experience mode. The official test is basically, it runs the benchmark with all the default setting, the standard settings. The native test runs the benchmark at the native resolution of the device. This is only for mobile and tablets. The VRS test is a separate category of test, is a new thing implemented. It's a new feature implemented recently. And there's a test which can run on variable rate shading supporting devices. So it will output a different result. And the custom test allows the end user to modify the parameters and customize the test, while the experience mode runs the test time-based in a game-like environment, game-like view. Now let's have a deeper, a more detailed view on the actual benchmarks which we have developed lately. So we continued the cross-platform approach, the tradition from Basemark GPU, the former benchmarks which we developed. But this time we are targeting separate categories individually. So we have a benchmark targeting the high-end discrete GPUs, ray tracing supporting, and that is Relic of Life. A special dedicated benchmark for the mobile sector, mobile and tablet sector, which is the Expedition, and the most recently released benchmark, Sacred Path, which targets medium tier hardware, but from premium smartphones to mid-range discrete GPUs. Relic of Life is the benchmark which we are very proud of, because it's the first real-time ray tracing benchmark running on Vulkan. It has been released in March 22. As features, as ray tracing features, it has reflections with multi-bouncing reflections and global illumination, and it runs on Windows and Linux. Then we have the Expedition, which was released in August 22, which is a special benchmark targeting mobile devices and tablets. It runs on iOS and Android, and the most distinctive feature of it is that it has a special VRS test. And the most recent benchmark that we released is Sacred Path, released last week, and is what we call the first true cross-platform benchmark, because it enables running the very same content, the exactly same content on both mobile and desktops as well. So on the whole range of devices, from mobile, from premium smartphones to discrete GPUs, you can run Sacred Path and you can put them side by side and see how they relate to each other and how far they are from each other. Obviously, the desktops are still ahead of the mobile, but mobile is catching up. And this is basically opening the door for our next product, which we are already working on right now, is called In Vitro. And it will be a benchmark targeting ray tracing mobile devices. So we will get soon to more details about this upcoming benchmark. It will be only on Android for now, and as ray tracing features, it will focus mostly on reflections. So thank you very much.
All right. Thank you, Mircha. See that the time is going very fast here. And next up, we're going to have a little bit of a panel discussion focusing on GPU benchmarking and best practices for GPU benchmarking. And this is something that Patrick is going to do. So please.
All right. Thank you, Sophia, and thank you, gentlemen, for joining for this discussion today. I'd like to start out with some really like classic topics about GPU benchmarking that have been around ever since late 90s that Tero was referring to back then. Not even only handheld, but actually all GPU benchmarking. One of the very like core topics for GPU benchmarking would be the repeatability of a benchmark. So you need to render the very same content every time on every hardware, or otherwise those measurements will not be worth much. So I'd like to ask Tim first. So how do you basically, as one of the very first GPU vendors in general, and especially one of the very first in handheld, you must have like run into this over the years, over and over. How do you see this achieved? Now, part of this is obviously the age-old question about time-based versus frame-based rendering, which one's preferred, and so on. But there's probably more to it also. So could you please tell us a bit about this? How do you make a repeatable benchmark?
Yeah, thanks, Patrick. I mean, I think this goes back to, if I were to start this question, is really think about the goals of benchmarking and ultimately what we want to achieve, as an IP developer, and ultimately what we need to exhibit when you're comparing different GPUs, different IPs, and understanding the users of the data. And so on the one hand, you can think of benchmarks sort of emulating real content and providing a representative workload that is therefore valid to be used in a performance comparison, because ultimately what somebody might be trying to do is to understand how this will perform in a real application, and thus time-based approaches are probably relevant. But if you take the point of view of understanding how do I compare like for like across a series of platforms, across a series of GPUs, then frame-based approaches are absolutely essential, right? You absolutely need an equivalent set of frames run on each platform in order to have a fair apples to apples comparison of the underlying capability of the hardware. And so we see very much the value of a frame-based approach, in order to fairly judge each GPU. I think there are other considerations that play into this too. I mean, the sort of debate between on-screen and off-screen, right? And the need to isolate, what is the contribution of the GPU, and this off-screen approach is again a sort of favored in a way of being able to compare like for like, and so not bringing in other overheads in a system through to a display pipeline, for instance, that then impacts the score. And then just as we will talk about, I think later on, thinking about the use of forthcoming techniques and understanding the relevance of these benchmarks in the context of new features, new things emerging through APIs. And as we've talked today, ray tracing is a good example of that. But yeah, so I think there's merit to time-based approaches in the way that emulates real content. But in terms of the underlying goal of benchmarking, if you see it as an aim to really provide a like-for-like comparison of capabilities across platforms, across different GPUs, then a frame-based approach, I think, is essential.
All right, thanks for this. As Sophia said, we're a bit pressed on time, but I would still like to ask Mircha. Now, you do primarily frame-based benchmarking in GPU score, but you take it even further. You actually only display primarily every 9th frame. Now, I remember already in like late 90s, frame-based benchmarking was criticized for not being as entertaining to watch. One could say that rendering only the 9th frame would make it even less entertaining to watch a benchmark. Now what's your take on this?
Yeah, well, now, what do you prefer? Do you prefer an accurate benchmark, or do you prefer a nice, good-looking benchmark, right, wrapped nicely with the ribbon and such? So, in terms, yeah, in terms of looks, indeed, a time-based benchmark probably would look better than a frame-based. But we prefer to go for the accuracy here. So yeah, as you said, in our benchmarks, we have only the 9th frame visible on the big screen, because the other ones, the 8 frames in between, they are rendered in the film strip. So we make sure that all the frames, we want to make sure that all the frames, they are rendered by the benchmark while running the benchmark. So we want to make sure that there is no frame skipping or frame blending or any other driver trickery out there. So yeah, considering the variety of devices and the performance differences that you may get, we want to make sure that the same content is rendered each time. So thus having an objective and an accurate evaluation. So basically, the same 9 frames which we render in one benchmark or on one device, they will be exactly rendered on other device, on all the devices, basically, that are running our benchmark. So the only difference will be that on one device, the frame will be rendered like in 1 second, while on other devices, it will be rendered in 1/10 of a second. And that is basically what would output the score, the difference between the capabilities of the devices. So yeah, we prefer to go that way, but we still have the experience mode for the hardcore users, which want to see a game-like performance or a game-like look. We have the experience mode in our benchmark, which runs smoothly the whole benchmark, but it doesn't output the score.
All right, thanks for this.
Thanks.
And another thing, which also age-old discussion is this whole question about different GPUs having different architectures, and thereby questioning, can you then run basically the same code on each GPU and still get results that could be considered genuinely comparable? Now we see in the PC space that all the famous games usually have GPU vendor specific optimizations, and then if you benchmark using these games, you actually will run a bit different codes for the different results. Now in handheld, obviously, especially Android, you have a wide variety of GPUs, wide variety of devices using them, and even wider variety of games. So how does this work in handheld? Tim, could you tell us about this?
Yeah, I'm almost going to sound like a broken record and go back to the goals of benchmarking again, right? And I think this objectivity factor is key, right? Because absolutely there are variations in architecture, variations in optimization paths, but I think you've got to look at what you want to get and understand that there are various different abstractions, various different benchmarks and applications that may be run in order to get a feel like of the GPU that you're evaluating. And thus, yes, there'll be instances where running a fixed frame-based same code path benchmark would be perhaps not reflecting real world performance once you factor in those optimizations that are made. But the value you get out of that is, an understanding of the underlying, fundamental capabilities. But you can, there's a case to be made for that alongside, other benchmarks, other applications that you do as part of that full evaluation that then do reflect, the deeper collaboration perhaps between, game engines and GPU vendors in terms of delivering that full sort of real world performance. And it's, I guess, also worth noting that mobile optimizations is was called out earlier in this webinar are different to those that you'd make in the PC space. So getting that full cross-platform, independence is very difficult, but you kind of need to go back to the fundamentals within, a specific benchmark. I think of the likes that Basemark are providing, on the understanding that there will be optimizations and other things that will exist in other content, and there are other ways of evaluating that. That would be my view.
All right, thank you for that. Now, Basemark creating these benchmarks as like considered appropriate ever since late 90s, collaborating with the GPU vendors. Now, Mircea, you're basically the person who then collaborates with the GPU vendors like Imagination here. Do you often get then like discussion with the different GPU vendors about having different optimizations for different GPUs in order to then like display their performance optimally? Is this something you have run into, or do you actually use different code paths in GPU's core?
Well, not really, but of course there are differences in the implementations. I mean, we are talking about different APIs. We are talking even about different operating systems. So there are differences that we have to take into account, obviously, but the implementation, the ground-based implementation, we try to keep it the same. For example, I can give you a quick example of ray tracing, the ray tracing implementation on DirectX and on Vulkan. The implementation which we have in our engine in Rock Solid is very look-alike. Is quite similar, I can say. So we don't want to go like for DirectX we have ray tracing pipelines, and for Vulkan ray queries. No, we cannot do that. We will have the same thing for both, for all the supportive APIs. Now, of course, if we talk in Metal is a bit of a different thing, and it uses a different approach. Therefore, we don't have ray tracing benchmark for Metal yet. So what we can do on a common base, we do. So we don't look for differentiating. We hope that the only differences that the end user will get in the end is basically the difference from the hardware, so not from the software implementation.
All right.
I hope this answers your question.
Yeah. Thank you very much for this. Now, after talking about subjects from late 90s, let's go to today and ray tracing on handheld. There are some skeptics wondering that why all this noise about ray tracing on handhelds. Is this just the only significant new feature in handheld hardware, and that's why it's so much hyped and nothing else, or how do you see this, Tim?
Yeah, I think that's, the skeptics are interesting, right? I think Tero said ray tracing's finally here in a form that is both performant and power efficient enough to be in a in a handheld footprint. And I think that's what we're seeing here actually is we're going to be on an evolution, right? Where classic rasterization as it exists today will exist today, and I think we'll see hybrid approaches with ray tracing alongside rasterization to improve visual quality in the ways that Christoph presented earlier. And I think what that's one of the reasons why we think it's critical for companies like Basemark to produce content that begins to take advantage of this, and to be able to benchmark the different GPU capabilities in this area, so that you can show the different effects and show the effectiveness of the innovation we're seeing in the mobile space. In terms of what else is coming, I mean, VRS is now in the mobile space. It's great to see that in the Basemark lineup, and I think we're seeing other rendering algorithms in wider game engines around probe-based global illumination, increasingly the use of compute shaders to provide flexibility and additional performance within geometry processing. And we think that's going to come down, right? That's in the same way so much of what we see in mobile just cascades from what's happening in the desktop space. We expect the same to happen here. And so this is why, in addition to the objectivity and the things that we've discussed, it's really important for companies like Basemark to use these modern techniques as they emerge, as the APIs provide support for them, so that we can evaluate the adoption of these features. And ultimately, mobile hardware is really capable of delivering some impressive visuals these days using these techniques. So this close cooperation, these partnerships that we have together are really important to be able to showcase that. So, one of the reasons we're very happy to be here with you on the webinar today, right? Because I think this cooperation is key as we then evolve benchmarks to take advantage of these over time.
Thank you. Thank you very much for that. Now, we're obviously running out of time here, but I would still want to ask Mircea here. We have very few actual handsets out there doing ray tracing today. We practically don't have any games using that yet, probably because of the lack of devices. So is this still the right time now to then create a benchmark about handheld ray tracing?
Well, we had one lesson learned, I would say, with Relic of Life, because Relic of Life was ray tracing benchmark, but it was not the first out there. We were the first on Vulkan, though, with Relic of Life. So we learned from that a benchmark should come on the market when the market is still very fresh. So not at the end, when the demand is getting lower and the technology is already old. So the benchmark should be there at the beginning, from the start, because that will give the momentum to the whole development and the gaming industry as well. You mentioned there are no games yet in the industry. Well, there aren't, because the ray tracing mobile is not yet that known. I mean, ray tracing on mobile just barely started this year, I would say, for the public, for the end users. So the times for developing a game, it's still quite a while. So the market indeed is very limited at this moment, but the ray tracing supported GPUs are already being produced, and the deals between the phone manufacturers and the chipset OEMs, they are ongoing, and I'm pretty sure that next year we will assist to some new releases out there on the market in this industry.
All right. So, yeah. Thank you very much for that, and thank you, Tim, also for your insights.
All right. Hello again, and thank you, Patrick, for that. Sorry, we're a bit over time. Time goes fast. We have now, in the last thing on our agenda is the Q&A session. And for that, we're going to have most, I guess, Tim and Mircea and Patrick answering the questions. So I see that there's been a lot of you who has asking questions in the chat and in the questions tab. Yes, we like that. And I guess we could get right to it. I guess it's a Basemark related question, or Mircea. How will the benchmark work with software like ray tracing how will the benchmark work with software ray tracing engines like Adshars and so? Did that?
Yeah, I'm not sure I fully understand the questions, but this question. But well, our benchmark is focused is based on the GPU performance. So the CPU, well, there in our benchmarks, basically there can be um, there can be in the benchmarks there can be some cap due to the CPU bound, and this is something which we want to avoid. I don't know if this answers the question,
Sorry.
but yeah, we can continue on this one separately over emails.
Yeah, sorry if my also this jargon in this industry, I have not gotten it yet. So if I'm pronouncing something wrong, it's probably possible. Sorry about that. Another question for Basemark: does Basemark work with immediate mode as well as deferred?
Okay, yeah, this goes a bit technical.
Oh.
This goes very technical. So yeah, I think we will continue on this topic separately over email with whoever asked the question.
Okay, yeah, I will check it out. Well, let's go into have some imagination questions, or not only to Basemark. Okay. Now there's some industry jargon. I'm sorry, but let's try it. How does latency of ray queries is how is latency of ray queries how is it being hidden? Is it hidden on hardware level or some software level, or?
Yeah, so I mean, we're getting into the technicalities here, but yeah, so you can imagine array query being handled like any other sort of closely coupled hardware request from a shader stage. So indeed, that's hidden in the same way any other, long latency access would be handled through a switch to another shader while that's being, acted upon. So yeah, there's basically support in the same way you have similar things like texture requests in shaders today that you could switch to. We basically have the same with ray queries as is suggested in the question.
All right. Then following next question has something to do with massification of ray tracing for mobile support on UE and Unity.
Could you read the question,
Sorry.
Sophia?
Yeah, my question has to do with how you see massification or ray tracing for mobile support on UE and Unity.
Okay. Yeah. Well, I suspect that they will have to adapt to the market. So I feel that the market now is, at least the mobile market, is barely developing at the moment. We have just the first entries on the market. Now, obviously, the engines will have to will need to have enough hardware, so to say, available on the market in order to produce a consistent product. But yeah, probably the evolution would be slow, or at least in the beginning, but I'm pretty sure that it will happen. So I'm pretty sure that they will start supporting the development for mobile RT as well. Tim, maybe you have something more to.
I'd agree. I mean, companies like ourselves, and engage game engines and understand the sort of chicken egg problem here between having hardware that's capable of support, whilst hardware vendors who want to spend silicon area on this stuff want to know that it's going to be used and it's a worthwhile investment. So I think this is a sort of a chicken egg problem, but there's a building capability, I think, within within mobile GPUs today. And as you say, there'll be slow adoption as that becomes more fully featured, and it's just on GPU providers like ourselves to work with the ecosystem and try and develop that over time. But it will be a gradual process.
All right. I see that we don't have too much time, so I guess we're into the last questions here. For imagination, for you, Tim, for sorting rays, are you sorting the whole family as rays, like primarily plus child rays, or not? And if not, how do you deal with sorting of child rays?
The short answer is yes, we sort the whole family of rays. And so the whole essence of this is that we're able to bundle rays that are likely to be tested against the same node in the overall acceleration structure. So yeah, it applies both to primary and secondary rays in the system.
All right. I think we have to end here. We're all already over 45 minutes, unfortunately. And we're so happy to have a question. And hopefully we can answer them offline via email. Feel free to reach out to us at Basemark if there's any Basemark related questions or to Imagination. We're happy to answer them. And thanks, Tim, for joining, and Imagination, and to my colleagues, Mircea and Patrick, and Tero. And to everyone of you who was watching, thanks for joining, and I hope we will see you at some other time later on. Great. Have a nice evening.
Thanks,
Bye.
everyone. Bye-bye.
Thanks, everyone. Bye-bye.